Hello, y'all. This is a quick lesson on matching R values, which are correlation coefficients, with a graph. So a correlation coefficient determines or measures how closely related two variables are. And it's the sign of the correlation coefficient relates to the slope of the regression line. So this is for linear regression equations and analyzing linear data, basically. My hope is that after looking at these, that it will provide some clarity as to being able to decide which graphs match which R values. So being able to decide how closely related two variables are. So correlation coefficient determines the strength of the relationship between two variables. And it will always be between -1 and 1. -1 indicates a very strong negative relationship between the two variables, and +1 indicates a very strong positive relationship between the two variables. And what I mean by positive and negative relationship is a -1 indicates a negative slope. So the line would be falling, which means that as one variable is getting bigger, the other variable is getting smaller. We call that an inverse relationship. And then a correlation coefficient of 1 indicates a positive slope, which goes up like this, which indicates a direct relationship. As one variable is getting larger, the other variable is also getting larger. So if we were talking about buying items at a store, this is not statistics, but the more items you buy, the more expensive your bill is going to be. Or if we're talking about rain in a barrel, the more time that passes, the less water there is in a barrel. So that's an inverse relationship. I gave two different examples there. So I have a couple pictures here, and we're just going to practice matching the R value with the appropriate graph. A -1, R value of -1 indicates a very strong negative relationship. It doesn't necessarily mean that the line is steeper. It just means that the dots, the points in our set, are very closely related. It follows a very strong linear pattern. So which of these graphs would you suppose, would you guess, follows a very strong negative pattern, a very strong negative relationship? If you guessed the right one, then you were correct. It's not necessarily that the slope is -1, it's just the strength of the relationship. So as x is getting bigger and bigger and bigger, the y values are falling, they're going down. So it has a strong negative relationship. And then the value of the r, which is 1 in this case, means that these points follow a very strong linear pattern. They're really, really close together. So that leaves that the other one, r equals 0.4. The positive 0.4 indicates a positive relationship, so the line should be going up. And then 0.4 indicates not a very strong relationship, which makes sense because these dots are really spread out. So generally speaking, if we were to circle all these points, it does have a linear trend, but maybe not, maybe the variables are not very closely related. And if we were to go on to find the coefficient of determination, maybe we would see that this line isn't a great fit for the data, which we'll look at later. But that's kind of where this is leading, is we're using these values to determine the strength of the relationship between two variables, and then later we'll determine whether the line is even a good fit. So in the next one, go ahead and try it. You're matching an R value of -1 and an R value of positive 0.8. So which one do you think goes with which? This one, hello, Sergeant, would be a relationship of -1 because it is falling and the dots are really close together. And this one is 0.8 because it's positive and the dots are pretty close together, but not like this. This is a strong relationship. So you can even see between the 0.4 and the 0.8, the difference in those. 0.4 was really spread out, still positive, and 0.8 is still spread out, but closer. So if we were to circle this data, we have points that are getting closer and closer to that line, whereas over here is pretty spread out. Okay, try this one. Hopefully you found that this one is an R value of 0.5. It is a positive relationship and our dots are pretty spread out. And then this one, it's just scattered. It's just everywhere. So there's pretty much no relationship here. This might be car color and height. I don't know. I'm just making something up. No, it can't be color because color's qualitative. Car, age, and height. Those are the wrong values, but that would be an example of something that probably has no relationship. Okay, try the next one. We've got an R value of 1 and an R value of -0.9. So this one would be an R value of 1. This one would be -0.9. Now, if you're having trouble deciding, this one was nice because we had one that was negative and one that was positive. So that should have given it away right away. This is negative because it's going down. And this one is positive because it's going up. Not very steeply, but it is going up. And that 1 indicates that these values are very closely related in a positive relationship. So at a value of 1 or -1 is going to be pretty much linear, pretty much right along the line. And then -0.9, you can see these dots are really clustered together around this line in a negative trend. Okay, two more. R value of -1 and R value of positive 0.9. Go ahead and try it. This will be our -1. This will be our 0.9. And again, if it helps to circle your data to help you make the decision, then that's a good idea. Or highlight or whatever. Last one. R value of 0.5 and R value of -0.3. So again, this one makes it easy because one is positive, one is negative. So we already know that this one is positive, this one is negative, which by that alone, you can decide which one is 0.5 and 0.3. So this one has to be 0.5 and this one has to be -0.3. Now, I would have liked this one better if they had both been positive, and that way you could see the difference between a relationship of 0.3 and a relationship of 0.5. But if you can pretend for a second that this one's positive, it's not, but let's pretend. And note how spread out the dots are compared to this one. Both of them are spread out, but 0.3 is more spread out. So it has not as strong of a relationship as 0.5. So if we were to compare 0.5 and 0.9, then we can see the difference there. 0.9, we've got them, kind of clustered close to the line. 0.5, we have a little more spread out. So hopefully that helps you be able to decide the difference between the two graphs. And then I want to point something out very important down here. Does a correlation coefficient of 1 indicate cause and effect? Why or why not? And I wanted to point this out because you, especially if it's an observational study, pretty much any study, but especially an observational study, just because the R value equals 1 does not indicate cause and effect. It only indicates association. So a cause and effect relationship cannot be concluded from an R value because the R value only indicates association or relationship or correlation. There could be the possibility of too many confounding variables to conclude cause and effect. We can't see that from a statistical study. I would even be hesitant to say this, but in a designed experiment, you might be able to loosely say this causes this because it's so controlled. A designed experiment, you have the treatment and the control, and it's all random, and within the groups it's random, and so maybe then you could, but even then, if we're just given an R value and nothing else, you cannot conclude cause and effect. You can only conclude association or correlation. So that's all I have for this lesson. I hope you enjoyed it. I hope it helped clarify some things. If you have any questions, please let me know and I'll be happy to help.